Hello, everyone. My name is Roberto Kompany, and I'm a principal analyst with Omdia. Today, I have the pleasure of joining Martin Olsen from Teledyne LeCroy for a fireside chat, and we will talk about Open RAN and some of the challenges that the industry is facing in deploying multi-vendor Open RAN networks. So, hi, Martin. Thank you for joining me on this short fireside chat. Can you please give a brief description of your role and responsibilities in the organization?
Sure. I'm working as a global business development director here at Xena Networks, and I'm kind of responsible for the Camira product here. So the product is mainly targeting for O-RAN customers that are including network operators, both greenfield and also brownfield, and also equipment manufacturers of RUs, DUs, and CUs, as well as system integrators.
And thanks for that.
So we are now pushing some questions, and we hope that you will answer these 3 questions just to set the scene for the webinar. And it would be interesting to see what you guys think regarding how important do you think testing is for the successful deployment of Open RAN. And we can already see people answering now. That's great. And it's great to see that 50% think this is extremely important. And we do not have anybody who think it's not important or somewhat important. So thanks for answering that one. Let's just take one more. How prepared is your organization to undertake Open RAN testing? Will also be interesting to see. And here we have a bigger spread on the answers. Wow, that's more or less equal from, but at least 31% is saying somewhat prepared, 15 is not prepared at all, and then we have 15 that are very well prepared. Interesting. And let's take the last question here. What is the biggest barrier your organization is facing in effective Open RAN testing? Good. So here we have both a good spread as well, but the high runners are limited technical expertise, but the biggest one is a lack of test tools and resources. And the second one is difficulties in vendor collaboration. So thank you very much for answering these questions. I think that sets the scene pretty well for this webinar here. So let's get started.
Great. And I think these survey questions were really interesting because it sets the scene, as you were saying, Martin, in terms of testing what's required in Open RAN. And in fact, very recently, I published a report called The Opportunities for SIs. And this also delves into much of the topics that these questions asked, and in fact, some of the responses that the respondents said. Let me now share with everyone a slide from one of our very recent surveys, Open RAN surveys that we at Omdia have carried out. Can you see the screen, Martin?
Yes, we can.
Okay, great. So as I was saying, this is one survey chart from a number of questions that we put in. It was a survey that we did with about 106 respondents, operator respondents globally. And in this particular instance, we asked them, what are the main barriers to multi-vendor Open vRAN adoption? So let me just quickly explain. At Omdia, we call it Open vRAN, Open Virtualized RAN. So that's, as everyone I'm sure understand, it's when you virtualize not just the CU, but also the DU as well. So in this particular instance, we're looking at some of the top challenges that these respondents have said, and it's very close to what you were saying in those questions, Martin. Integration of different vendors being very complex. So the results, in fact, they're showing of this year is 2023, rather last year now, and the previous iteration of the survey that we did, the same question was asked in 2022. And so for the first one, the first category, we see that they're more or less the same. So about 44%, the integration of different vendors is very complex. For the second question, or rather the second category, is the integration of legacy networks is very complex. That's also responded by 40% in 2023. Very interesting is how vendor choice is now, people believe that it's now not so limited in 2022, but in 23 it's now improving. So in terms of new vendors not yet proven, many people think that 39% in 22 think it's not proven, but this has actually improved in 23. So as you can see, there is quite a bit of work that has to be done. The last category is quite interesting. There is no significant barriers. So only 1% of the respondents in the 23 version suggest that there are no significant barriers. So I think that speaks quite well to what you were saying and those questions that you put, Martin. So let me now move on and ask you a little bit about Xena Networks, because from my understanding, Teledyne LeCroy has acquired Xena Networks. Can you maybe explain a little bit some of the major products from the Xena Network side and how they might benefit the Open RAN vendors and the CSPs on this journey?
Sure. Yeah. Yes, that's correct. We very recently got acquired by Teledyne LeCroy, who is also a known name in the industry for the scopes and storage testing solution and protocol analyzers. And Xena's main products are consistent of layer 2, layer 3 Ethernet traffic generators, which is mainly targeted for NIMs and semiconductor companies working on switches, NICs, transceivers, stacks, AOCs, etc. And can help with the performance testing and system verification. The traffic generators can, example, be used to test if a certain quality of service, bandwidth, jitter, or latency are meeting a SLA, etc. Another product we have is called Chimera, which is a network impairment emulator. And as you rightly mentioned in your report, while O-RAN promised to give operators the option to disaggregate their networks and be able to pick and choose from multiple vendors for their network, it also results in the challenge of successful integration of these multiple vendor solutions. The front haul network, that is the connection between the RU and the DU, is Ethernet based or eCPRI. And eCPRI is an evolution of the CPRI, which was used in the legacy networks. eCPRI brings some improvements compared to CPRI in that it's packet based, and unlike CPRI, it can be split into various functions and thereby reduce the front haul interface bandwidth requirements. The RU and the DU is connected via many switches, and the distance at which RUs and DUs and CUs can be placed can vary based on how operators actually want to deploy their networks. This is also where network emulators can be a key element to test robustness of systems and also the tolerance of different components by impairing, for example, packet drop, duplications, misorder, burst, jitter, and latency, and then see how the system react and where the boundaries are. This is done wire speed at all speeds from 10 gigabit to 100 gigabit, and it can be done with up to 8 different flow filters per port.
You mentioned eCPRI as sort of cornerstone of O-RAN network. Can you explain a little bit more why it's really important to test that?
Sure. So Unlike the proprietary protocol running CPRI in the 4G networks, 5 gig or 5G front haul networks uses the more standardized eCPRI protocol. The eCPRI is responsible for transferring data, both the user data and also the control data flows between the distributed units, the DUs, and also the RUs, the radio units. It's also used to control how the data moves between the RUs and the 5G antennas. And any issues with the eCPRI can affect the data transfer and potentially lead to loss of user data and also control information, which lower the voice quality, or in worst case scenarios, also loss of connection. So this means that the eCPRI is vulnerable to network impairments. As a critical component of the front haul, it's important that the 5G equipment operators and also manufacturers rigorously test how the eCPRI responds to impairments in their network setups. An example of this is test what happens during, for example, network congestion, where lower priority traffic is dropped for shorter or longer periods of time. Another thing is the P2P protocol, which ensures that various network components are synchronized, which is another critical element to ensure that you have a well-functional network. So the network emulation and traffic generation can also be combined, where Xena is offering some unique solutions where both the setup and control of both can be controlled from the same user interface, and as well from the same automation system.
Right. And network into disaggregation that you touched on is really an important topic within Open RAN, and it's a trending topic within the industry. And I think that's almost where the complexities come in. I mean, from my own research, I know that there are several drivers for Open RAN and why the industry is pursuing. Some of those that we've described in our reports is, for example, operators' desire for greater vendor choice and diversity, cost saving, an increasingly important issue for operators, especially in today's environment, and flexibility and agility to be built more into the network. So with that said, what are the challenges in testing which you can point me to in terms of what the network has to do and what you need to change, or in case there are impairments? Can you maybe describe a little bit those challenges and what you and your partners are doing in this space?
Mm-hmm. Yeah. So Chimera can help replicating real network impairments in the lab, which means that you can test the performance of CU, DU, and also the RU when they are subject to real network impairments. These CU, DU, and RUs, all three components, might be coming from different vendors. So it's important that at some stage that they are tested together for impairments to see their performance before they are actually deployed in a real network. This is where system integration testing becomes very important. Take, for example, how do you know that your DU from vendor A will work fine with the RU from vendor B, C, or D when, for example, certain latency or jitter parameters are applied? Or how does adding latency impact the throughput? Our test solution can help answering these questions. We can help you to test the unknowns, or what some others will call what-if scenarios. What we also see is a number of NIMs who are building these products, and also the network operators who are the consumer of these products are also working closely together with the system integrators who are who have multiple vendor setups, where others are building this capability in-house to be able to do more of that testing. So in O-RAN testing setups, our system is being used both by NIMs system integrators, as well as the network operators.
Great. There are a number of industry collaborations. Can you maybe explain and suggest if you're involved with any of them, such as, for example, ORAN's alliances, Open Testing and Integration Centers labs, OTIC labs?
Sure. We are actually very actively participating in the ORAN Alliance Blockfest across the globe. The Blockfest is a place where various companies meet and plug their equipment together to see how they operate and interoperate together. OTIC labs are actually doing a great job here in bringing in multi-vendors together to showcase their progress in the ORAN space. And you could say that we, in our small way, are also helping by providing Chimera network emulator solutions at the different OTC Blockfest to help them simulate the real-world network environment. Just in this fall, we have participated in Blockfest at the Array Lab in Taiwan, and also with the Sonic Lab in UK.
Mm-hmm. You touched earlier on latency. Can you please briefly describe a little bit what latency is and why we need to test for it?
Latency is actually one of the key parameters in ORAN. There is a strict delay and jitter parameters that the NIMs should adhere to. As I also mentioned earlier, the RUs and DUs can be placed a few hundred meters or few kilometers apart from each other, and depending on how operators want to deploy it. And moreover, the connection is Ethernet based with multiple switches in between. And the distance and adding in these switches do impact the latency, meaning how much time it takes a packet to reach from the DU to the RU and vice versa. Now, as a vendor or as an operator, you should be aware on how much latency your device can handle before you start seeing packet drop, which can impact the throughput, or that for example, the RUs are getting out of sync. So what what we do is that we help simulating the delay using our Chimera solution, and you have just to simply input the amount of delay that you want to simulate, whether you want a few microseconds or some milliseconds, and this can be done with actually nanoseconds precision. So a simple test scenario is that you test a test scenario where you automate, where you start, for example, at a very low latency, let's say of a few microseconds, and then you keep adding a few microseconds until you start to see that it impacts the RU and the DU. And this testing is very simple and can be done with just a few clicks. So it's not something very complicated, and it's something that can be set up very fast. If we look at the ORAN Alliance, in their specifications, they do also mention that the use of network impairment emulators is one of the key tools to be used for effective testing. Very recently, we also made a case study with Parallel Wireless, where they explained how they are using Chimera for this kind of testing and the benefit that it brings to these guys. I can strongly recommend to read that one, and we will actually share it in this webinar here a little bit later. So hope you will read that one.
Another question I wanted to ask you was, in the industry, we talk a lot around automation. What does that mean to you in the context of Open RAN?
Automation is especially relevant to enable vendors to assure performance of their network equipment and also software before they are delivered to network operators. It also enables network operators and service providers to plot their 5G RAN performance landscape, and it's actually possible to do at a fraction of the cost and time. Um, and with very high accuracy. This is because testing can now be performed in the lab, where a broad range of scenarios can be tested that are often very difficult, if not impossible, to perform in the field. So the lab test setup with the network environment testing equipment controlling a comprehensive automation test script that drives the system through a well-defined and repetitive test scenario really can help vendors to ensure updates are quickly tested and also verified before they start deploying these.
Okay, great. Let's see if there are any questions now from the audience. If anyone has any questions, please do put them into the question icon on your top right hand corner of the screen, and we will attempt here to respond to you. So there's one question, Martin. Can you elaborate a little bit in terms of what kind of automation solutions Xena offers?
Yeah, good question. So we have at Xena a product called Xena Open Automation. We also call it XOA, which is an open source test automation framework for use with the Xena solutions. It's very easy to use and very flexible. And the XOA features a Python API that actually runs on any OS. You can also use it in many different ways, but the typical three ways we see it being used is that, for example, customers might have an existing automation test system and just want to add the Xena solution into that one. Here it can be interfaced either through the XOA command line interface or the XOA Python API. It also might be that the customers want to utilize the test suites that we're also providing, for example, the RFC 2544. And here it's the same interfaces that is being used, the CLI or the Python API, to also control and get the benefit of these test suites. And the third one is that customers don't have an automation system already, and then just take the XOA and use as their future Ethernet testing automation system.
Great. So if there are no further questions, we will come to the end of this webinar. So I just want to thank everyone who participated. I think this was really, really informative, Martin. We do have prepared a short question survey, and we would very much appreciate your feedback on what you heard today, so we can always improve on these. And with this, I say thank you so much for joining this fireside chat, and any questions you might have, either to Martin or to myself, please do reach out to us. Thank you.
Thank you.
Thank you.